Hello viewers, today in this program we will discuss compound interest. It is a very important topic of business mathematics. It is very useful to calculate interest on interest, that is the compound interest. It gives the more rapid growth of the amount deposited. Compound interest can be thought of as interest on interest and will make a deposit or loan grow at a faster rate than simple interest, which is interest calculated only on the principal amount. Since it is the interest calculated on the interest, therefore, your amount grow faster than the interest that is calculated only on principal amount. Formula relating compound interest. If P is principal amount, N is number of periods, R is rate of interest per period, A is amount after N periods, then the total amount A is equal to P 1 plus R upon 100 to the power N. This formula is generated by using the interest calculation per period and summation of all periods. Now we discuss formula relating population growth. If P naught is population at beginning, R is the rate of population growth per period, Pn is population at the end of n periods, then Pn is P naught multiplied by 1 plus R upon 100 to the power n. This is similar formula as compound interest formula, but it is applicable to population growth calculation. Now we discuss the formula generation of this compound interest. The formula is generated by calculating interest on the amount after every period of time. Let P is the principal amount and R is the rate of interest. The amount after one period of time is A is equal to P plus P into R upon 100, that is P 1 plus R upon 100, we call it P1. This amount is the amount calculated by simple interest on one period of time. Now we calculate the amount after another one period of time. A2 is equal to P1 plus P1 into R upon 100. A2 is equal to P1 plus R upon 100 plus P1 plus R upon 100 into R upon 100, that is P1 plus 2 R upon 100 plus R upon 100 to the power 2, we call it P2. Here we have calculated simple interest on the second principal P1 and find the third principal P2. Now we calculate the amount after another one period of time is A3. A3 is equal to P2 plus P2 into R upon 100, that is A3 is equal to P1 plus 2 R upon 100 plus R upon 100 square plus P 1 plus 2 R upon 100 plus R upon 100 square multiplied by R upon 100. Therefore, A3 is equal to P 1 plus 3 into R upon 100 plus 3 into R upon 100 to the power 2 plus R upon 100 to the power 3. Here we have calculated this amount A3 by calculating a simple interest on the amount A2. If we calculate this regularly and so on after n number of periods, amount becomes An is equal to P 1 plus n into R upon 100 plus n into n minus 1 upon factorial 2 multiplied by R upon 100 to the power 2 plus n into n minus 1 n minus 2 upon factorial 3 multiplied by R upon 100 to the power 3 and so on. Therefore, An is equal to P 1 plus r upon 100 to the power n. This formula is generated by using binomial theorem. We have a plus b to the power n as a plus n a plus n n minus 1 upon factorial 2 a square plus and so on. Now, I will explain you some examples of calculating in compound interest. An investment of rupees 25,000 earn interest at 9% compounded annually. What will be the value of investment at the end of 5 years? Its solution. Investment is equal to rupees 25,000. Rate of interest is equal to 9% per annum. Time is equal to 5 years. Using the formula A is equal to P 1 plus R upon 100 to the power n, we get A is equal to 25 multiplied by 1 plus 9 upon 100 to the power 5, that is equal to rupees 38450. Here the calculation is performed by using log and anti-log system. Now, I am going to explain you another type of problem. Example second here is rupees 1750 are invested at 9% interest per year for 10 years. Find the interest compounded annually and half yearly. Part 1 of the solution here is interest compounded annually. Principal is equal to rupees 1750, rate of interest is equal to 9% per annum, time is equal to 10 years. Here P is equal to 1750, R is equal to 9, N is equal to 10. Using the formula A is equal to P 1 plus R upon 100 to the power n, we get A is equal to 1750 multiplied by 1 plus 9 upon 100 to the power 10, that is equal to 2390. Here we have calculated the compound interest for 10 number of periods using the basic formula of compound interest. Part 2, interest compounded half yearly. Principal here is rupees 1750, rate of interest is 4.5 per half annum, time is equal to 10 years, P is equal to 1750, R is equal to 4.5, N is equal to 20. Using the formula A is equal to P multiplied by 1 plus R upon 100 to the power n, we get A is equal to 1750 multiplied by 1 plus 4.5 upon 100 to the power 20, that is rupees 4220. Here we have calculated the compound interest by taking the number of period as 20. In 10 year we have 20 half years, and we have divided the rate of interest by 2, because the rate of interest in the question given as 9% per annum. So, it is 4.5% per annum. Now, I am going to explain you some another problem. An investment of rupees 50,000 earns interest at 9% compounded annually. In what time will the value of investment get doubled? Its solution. Investment is equal to rupees 50,000, rate of interest is equal to 9% per annum. Time is to find out. Amount is equal to 1 lakh, that is double of 50,000. Using the formula A is equal to P multiplied by 1 plus R upon 100 to the power n, we get 1 lakh is equal to 50,000 multiplied by 1 plus 9 upon 100 to the power t. Therefore, t is equal to 8 years approximately. Here we have calculated this value of t using logarithmic and anti-logarithmic calculation. In this question, time is to calculated when amount is doubled. Now I am going to explain you another example. Example 4. An investment of rupees 40,000 becomes triple in 12 years. Find the rate of interest that compounded annually. Solution. Investment is equal to rupees 40,000. Rate of interest is to find out. Time is equal to 12 years. Amount is equal to triple of 40,000, that is 120,000. Using the formula A is equal to P multiplied by 1 plus R upon 100 to the power n, we find 120,000 is equal to 40,000 multiplied by 1 plus R upon 100 to the power 12, that is R is equal to 9.587, 9.6% approximately. Here we have calculated rate of interest when amount is given, principal is given and time is given. Here the amount is 40,000, it is tripled in 12 years. So, the R is 9.6% per annum approximately. Example 5. What amount of investment become rupees 80,000 in 8 years at 8% rate of interest that compounded annually? Solution. Investment is to find out, rate of interest is given 8% per annum, time is given 8 years, amount is 80,000. Using the formula A is equal to P 1 plus R upon 100 to the power n, we find 80,000 is equal to P 1 plus 8 upon 100 to the power 8. We get P is equal to 43221. Here in this problem, the principal amount is not given. We have calculated using the same formula, and calculation is performed by taking logarithm and taking anti-log of the result. Example 6. The population of a city grows at the rate of 2.5% per annum if the present population is 2050,000. Find its population after 11 years. Solution. Present population P naught is equal to 2050,000. Rate of growth R is equal to 2.5% per annum. Time period is equal to 11 years. Using the formula Pn is equal to P naught 1 plus R upon 100 to the power n, we find P11 is equal to 2688000. Here in this problem, we have calculated the present population or the population after 11 year, when the population at initial period is given and rate of growth of population is 2.5. The calculation here is performed by taking log and again anti-log. Example 7. India's population according to 1991 census was 8.4 multiplied by 10 to the power 7, and it increases each year by 2% of what it had been at the beginning of the each year. Find the population in 2011. Solution. Present population is 8.4 into 10 to the power 7. Rate of growth is 2% per annum. Time is 2011 minus 1991, that is 20 years. Using the formula Pn is equal to P naught 1 plus R upon 100 to the power n, we get P20 is equal to 8.4 into 10 to the power 7 multiplied by 1 plus 2 upon 100 to the power 20, that is equal to 12.1 48 multiplied by 10 to the power 7. Here we have discussed various type of examples. In the last example, the population growth on the given census of the India's population we have calculated. Hello viewers, today in this part of program I have explained you the compound interest. The compound interest is very important part of business mathematics. I have explained you the generation of the formula of calculating interest, that is the interest calculated by the simple interest on the amount generated after every period of time. So, we have calculated the compound interest in n number of periods by the formula A is equal to P 1 plus R upon 100 to the power n. We have also discussed about the population by using the growth rate formula. Present population is calculated as initial population multiplied by 1 plus R upon 100 to the power n, where n is number of period and R is rate of growth of population for a period. I hope you must have enjoyed the program. Thank you.